Okay, now let's get started for the introduction for Java language. We are not going to finish the whole chapter 1 over here. And I try to give you some idea of what is Java language programming first. Okay, so let me bring out this. Okay, first one, what is actually the Java language? Java language actually is first developed by Sun Microcomputer. Okay, so this Zoom.us system actually you can actually annotate on it. So you click on the annotate and then you can do something like this. I can actually write on the screen.
Oh, okay.
You can do the same thing if you share the screen. So now let me clean it and then I stop sharing and you share your environment. Okay?
Okay.
So now I stop it. Now it's your turn. You share your screen. Now you try to share your screen.
Green.
In the middle there is a green box.
Oh, there it is. Okay.
And you pull it up and then you select the desktop.
Like that?
Yeah, I see it. Okay. Now you actually stop the sharing. I just want to make sure that you can share the screen.
Okay.
Okay, we need that. Now you stop it. Okay, now let me share it. So there could be a desktop. We can share by desktop, right? So you see something like this. And I can also share by whiteboard. Sometimes I can share by whiteboard. So if I want to write something, I can write to the whiteboard to explain it. Okay?
Okay.
So this one is for whiteboard. And then you also can share some application, but I don't want to demo it right now. So let me bring back to my screen, the share screen. First, Java language actually is a language designed for website construction. So the history is like this. In the early day, the first language is called Fortran. The first high-level language is called Fortran. It's called Formula Translator. Okay. So something like that. So it uses the Fortran, Fortran, for formula translation. Okay. As a first language that been developed for human scientific calculation. And you know what this language is for?
No.
The main contribution for this programming language. This one plus IBM 360, it actually performed a very important task for the United States. Even nowadays, project is still in use. And then its historical contribution can never be erased. The United States used the Fortran language and the IBM 360 to send humans to the moon.
Oh.
So all the mathematical calculation done by IBM 360 and Fortran language sent the first Voyager, the Apollo 11, to the moon.
Oh.
Yeah, so this Fortran language is very important. And that's the first scientific computation language. And then the second one, we have a commercial one that is COBOL language. Okay, that's COBOL language. That's for business use. Nowadays, still maybe a few percentage of the websites still actually using COBOL language for banking. Okay.
Website?
Yeah, it's actually also some websites as well. They actually access some database, but those databases are built by COBOL. Yeah, so it actually you may have a HTML, right?
Yeah.
But they say their bank system, the back-end banking is actually using COBOL language here, especially some older bank. Okay, so later this the Fortran language actually later followed by C language, and then C language followed by C++ at the year around 85, and then in early 90s it comes to Java. That's actually sometime like 90 to 92 start to have a Java. And ever since that, Java has been the de facto standard for website construction for quite a long time, especially for server side. Okay, you know what is server side? What is client side?
What?
What is server side? What is client side? You know what is the difference between website construction? What is okay? So
We said the difference between what and what?
client side and server side.
Client side. Is one of them like
client side and server side?
no?
Okay, client side is like you bring up a Chrome, right?
Yeah.
You bring up a Google Chrome. That is actually the client side.
Yeah.
Okay.
Mhm.
And then you kind of fill in your password or your name, right?
Mhm.
Those data being sent to server, say that server can be like Amazon. So that actually is server side.
Okay.
And then the server side, they do computation, and then when you get the result, it's sent back to your client side.
Oh.
So this side actually on the server side, the programming language is Java. The client side computation is using JavaScript.
What's that?
JavaScript is another language.
I mean, like, why?
Why?
Yeah.
It's actually of different nature. Java and JavaScript they are two different languages. Okay, it's not like it's not like parent-son relationship. It's a completely different language.
Yeah. What Java?
JavaScript is a script language. Java is a compiler language. Two are different.
Wait, what's a compiler language?
Okay. JavaScript scripting language is one by one. Say you say something, I interpret for you. Say you speak in English and I translate in Chinese for you. That actually is interpretation, right?
Mhm.
Say something, I echo something, or I translate it into Chinese. That's interpretation. And compilation is different. Compilation actually, you write a whole article, and then I actually translate it into Chinese for the whole article. That's called
Also, JavaScript does one line at a time. And
one line at a time. It's called scripting. Any language that's called scripting language is actually a interpreter based.
I thought Java did one line at a time to like
No,
line
different.
one.
No, different. So now let me show you what are the scripting language. The Python scripting language, that's one scripting language. So Python is a interpreter scripting language.
Okay. Oh, maybe okay.
Okay, Python is a scripting language. Okay, and then you hear, like I just told you, that JavaScript. JavaScript is a scripting language. Okay, so here it has the difference of the JavaScript and Java. JavaScript is a interpreter language. Okay, and then if you say right here, if you use a right mouse click, you can always see that here it has an inspect, right? You click on inspect, okay, and then you make it wider. Actually, here you will see the HTML file, right?
Yeah.
And then it will also show you the JavaScript on the right hand side.
Oh.
Okay, so that's actually when I click something, it downloads from the website, and then actually you show up in my computer. So that actually is download a JavaScript and it compute on my computer. That's actually this one actually is the local language, is a client-side language and used for that. But here, if I type the JavaScript language and I click this search sign, right? I click it, and then I'm waiting until it show up this different scene, right? Who provide this different scene for me? It actually is Google. Google's website provide this different information for me. Is that okay?
Yeah.
So that's the difference between client-side language and a server side. And also JavaScript is interpreted, is line by line, and then Java is compiled. So compile, it says that compile on server before execution on client. And this one, it actually is on the, this one is actually, execution is actually on the server side.
So does that mean like it collects all the Java programs?
So for example, if I had the JavaScript, right, like Google here, I type in this, right? This happened on the client side, but once I hit this button to search, that this query will be sent to the server side. So Google will compute that. And after Google finishes the computation, it will actually send the data back to my script. And that actually becomes a JavaScript job again. You know what I'm saying? So Java actually did the work behind the scene. Behind the scene for you. Okay? That's the server side. And then if you go to Citibank's system, the server side will do the job for you. But Java is not the only language for the server side. It also has the Python or some other language that can be used for server side. And the most popular server side language is the PHP language. It still took about 85% of it, but PHP usually is very simple. Java, Python are more complicated. So more useful website will be built by Java or actually by Python.
So Java and JavaScript kind of work together, like
kind of
to deliver.
One on your side, one on the server side.
Okay, and then so
now let's go back to Java. Our purpose is to learn the Java language, right?
Yes.
So that's one purpose of doing programming. That's actually web design, right? And then there are some other purposes. Say I'm trying to write a game for my own computer. That is another purpose. That's called desktop computing.
So Java is for it's for programming for the hardware?
No, it's not for hardware. Actually, it's for, you can write a game on it. So it actually is called desktop computing.
So you said
desktop means writing the program on your computer. Okay, writing the program. So these are called desktop computing. Desktop computing means what is desktop computing? Like I bring the program from here. This is desktop computing.
Oh, yeah.
Okay. Website programming means I use a browser and then I say browse for this textbook. That's actually is website computing. Is that okay?
Are you saying west side computing?
Can you repeat the question again?
So what is for?
Okay, website computing is that you use the Google Chrome or some browser to get the data computing.
Oh, yeah, never mind. I heard something else. Never mind. Yeah, website computing. Yeah.
Is that okay?
Yeah. So that's JavaScript.
JavaScript on your side, but on the server side. Is that okay?
Yeah. I'm confused about the part where you said that Java runs the whole program, all the lines simultaneously.
I don't get it. What's simultaneously?
Like at the same time.
At the same time, actually, you let me try to
like not line by line.
That's interpretation. You are talking about interpretation. So the client server is like this. You have a computer, right?
Uh-huh.
And then it can be a notebook, can be a cell phone, or can be your tower computer, right?
Uh-huh.
And then you have a browser, and then hit some button, and then you send to Google's website. And
yeah, I get that part.
Okay, and it send it back, right?
Uh-huh.
And when it send back a program on your own side, it actually is wrong on your, say, using the JavaScript on your own side. It's done line by line. It's called interpretation. Interpreter.
Oh, so like changes the whole program instead of.
It is not actually changing the program. It actually interpret the data for. It actually interpret the data. Say you have a JavaScript program, right?
Uh-huh.
And then you need to actually make it run by the computer. So that process is called interpretation. You know what I'm saying?
Yeah.
The computer doesn't run like in this text mode. It doesn't run in a high level language. It actually will be run in low level language. So in order to do that, you will need to translate into the machine code or bytecode in this case, in JavaScript case.
Oh, okay. Yeah, that makes sense.
So that is a translation from a high level language to low level language. So you need a compiler or a interpreter to do the job.
So both of them would work, right?
Both of them will work, but they work differently. So let me bring up another slide. Here actually is for programming language slides, and I show you the chapter 1 for this. So this one is a course for college senior course for programming language. Anyway, so here let me bring up to interpreter versus compilation. Okay. So here are 3 languages you may heard of these: Python, Java, and C++.
Yeah.
Okay, these 3 are actually translated in different ways. Okay, let's first talk about C++ language. You have a C program. You go through a compiler, so you finish the whole program, and then it translated by compiler, and it becomes a program. And then you put some input in there, and then you run it, and then you provide output.
Yeah.
Okay?
Mm-hmm.
That's called compilation. And then second way is interpreter. That actually you get some program in, you actually run it right away. So let me show you the interpreter. The interpreter is like, let me bring up a simple, this one is called Python script. Okay.
Mm-hmm.
So this one in Python console, I can type a equals 3, b equals 4. This one I probably showed you before, and print a plus b, right?
Yeah.
This one is called a interpreter. Okay. So a star star 2, that's a square, you get 9. Can you see the number or no?
Yeah. I didn't know that's how it worked.
So this one actually is a interpreter. Is that okay?
So it does.
It actually, I say something, it echo. I say something, it echo. So if I say c equals a plus b, and then print the c, this one is interpreter. So each time there is a triple arrow sign, triple greater than sign, and then that actually waiting for me to enter some command. And then
so
once it's finished, you will return the result to me.
So like interpreter, it takes in all the information, and then when you ask for it to display it, it displays it.
Yeah, it's like Q&A.
Yeah. Okay.
Okay. Interpreter is like Q&A. Let's go back to Java program. So right here, let me actually start simple Java program. So let me show you the P1, right?
So that makes sense. So Java, it wants you to write the whole program and then it runs it.
Yeah. So here, let me say public static void main, right? So I write a simple program. Say, okay, in between, I actually never provide anything, right?
Uh-huh.
So after I finish, I hit compile, right? And then here I hit for run, and you come out with the result. This is called compilation. Is that okay?
Yeah.
Similarly for C language, I may bring up a C language window.
Isn't that similar to Java?
Slightly different. Okay, I'll explain that later. Let me bring up the C language part. I C double plus language. Let me bring that another side. Okay, I just.
But you can write a compiler language in Python, right? Can you?
What was the question?
Can you write like a compiler type of code in Python?
Yes, why not?
But you can't write um, the type of code you write in Python into Java because it wouldn't print correctly, right?
No, actually, both way, either way is possible. So this one actually, I compile it, okay, and then I run it, okay. So this one is a compilation. So if I try to see the code over here, I try to see the code of this program. Actually, I need to bring up this programming tool, and it will show this is C language, okay. But I just did the compilation process over here, okay, using the window prompt. Are you okay with window prompt?
Yeah.
Okay. So that actually I use the window prompt to do that. Okay, that's called compilation. So let me tell you the difference between this one actually is for Python interpreter, right? And then let me tell you the difference between Java and C++. So we have this, and then we have the C compilation, and we have the pure interpretation, that's for Python. Or JavaScript. JavaScript is the same. So comparison, interpreter is more flexible. It has better diagnostics because you can see the result right away. Compilation is better for performance, okay? And then the third one is called hybrid. In fact, Java one is more like this one called hybrid. So Java has something called Java virtual machine. Okay, so the program that actually Java compiler compile to is called intermediate program. It's called bytecode, and that bytecode is actually can be shared by different platforms. So Python, Java is a platform independent language, but not C, C++. Okay, let me explain this. Okay.
Okay.
This called hybrid method is different from the C, C++ language method. Okay.
Oh, so C++ is a compiler.
It's a pure compiler. So here, say I have this Intel i7, right? And I need to have some machine code. And then my C language actually written by C, C++. This will translate for machine code in order for i7 to run, right? That actually is called compilation. This one is called compilation.
Okay.
And Java is a little bit different. Java, we have a Java code, right? And it compile not to the machine code, but into something called bytecode, right? It's some sort of intermediate code. Some sort of intermediate code, right? And then after that, you may have a Mac OS machine. You may have a Linux. You may have a Intel Windows, right? So this bytecode can be run by this different thing. And this different thing, there is a common software called Java Virtual Machine. Java Virtual Machine. Each one has its own Java Virtual Machine. And these different Java Virtual Machine are written by C language or C++ language. Each one of them, in order to translate the bytecode onto the right machine code. But for programmer like you just need to take care about Java part and translate it to bytecode. And then the Java virtual machine will translate for you into the hardware. You don't need to worry about it.
Okay.
Okay? This is called hybrid method. So hybrid method actually presents some good advantage compared to CC double plus way, because CC double plus, if I compile, it can only be for Windows, or it can only be for Linux, or it can only be for Mac OS. So it's only for one platform. So Java one with the hybrid method, it actually can cross the platform. So you wrote one program, send to your friend that is using different OS, say Mac OS language, it can all run on the different machine. Is that okay?
Yeah. Why don't people program like something like Java Virtual Machine for C++? Like, why don't they make it so that it's easy to use also?
It's slower.
Oh, okay.
One thing that's slower. Second, you at the end you still need some language to help you to do the translation to machine.
Well,
And you can just have Java. You still need to have someone to do the Java virtual machine for you.
But why don't I thought all code are like runs at the same speed as long as your computer runs at
No, different language run at different speed.
Oh, okay.
Different language actually run for different speed. Okay?
Okay.
Let me go back to here. Okay, so we have this type of compiler actually is called hybrid way. That's for Java.
Yeah.
So the three languages we introduced so far are of different compilation or translation scheme. So this is actually for Java. As you can see, Java program use the compiler into Java bytecode. And Java bytecode can have Java interpreter, that's actually Java virtual machine on Mac OS, and then Java interpreter on Windows, Java interpreter on Linux. So what? Java virtual machine itself is an interpreter, but Java is used by compiler to compile the Java bytecode. So that's why we call Java's way of doing compilation as hybrid. It actually has both translation, compilation, and interpretation. Is that okay?
Yeah.
And then Python is actually by interpreter. JavaScript is by interpreter. And then C# is by compilation. Is that okay?
Yeah.
Okay, so that's about the compilation. And then let me bring to different pages. So right here, we have different programming language, right?
Mm-hmm.
And here the bubble show you how much runtime it has on computer. So JavaScript has the highest runtime because a lot of people browse through the internet, right?
Because like Google use it a lot bit, right?
Yeah, you not only Google but also for Amazon, for Facebook. So most of the time you are running JavaScript right now.
Mm-hmm.
And then machine code is like this. You have a lot of binary code, hexadecimal code. I'll explain this later in AP course, okay? Because this is too much right now, too much to understand it right now. But the tactic machine code is something like this, okay? And then we have the high-level language like Java, JavaScript, Python. It can be translated to machine code or assembly code. And then machine code actually run on the hardware. And on the right-hand side, that's assembly code. Assembly code actually mimic the function for machine code. So there's a one-to-one mapping between this assembly code and the machine code. Is that okay?
Yeah.
So it's just a simple format that make people make the machine code more readable. It's in English, but it actually not as convenient as the high-level language. That's called assembly code.
So this code is a machine code, which is it's a little harder to use.
This code is called the assembly code. Assembly code has the one-to-one mapping to machine code.
Oh, okay.
And the real machine code that you actually run is like binary code. Is that okay?
Yeah.
And then And then the high level language is more English like something you can read, something you easier to understand. And this is the most popular language in 2016. Okay.
Yeah.
And then here are the family tree. I say the first language is Fortune, right?
Yeah.
And what's the contribution for Fortune?
Went to the moon.
Yeah, it's
enabled them. Yeah.
Yeah, it's actually so it's around 1960 something. Okay.
What?
And then COBOL is after that. He's been after that. August 60 after that, and then you see that August 60 is to C, C double plus, Java, and then C sharp. Okay, that's the scientific computation side.
Wait, why did Lisp? Oh wait, never mind.
Why did this not so popular, or what?
Like, why is it not even at a branch? Like, why is it not branched from Fortran?
Not popular actually.
Well,
As long as there's no market, nobody actually care about it. Let me show you some other pages.
and then
So here are the real world programming language of different purpose. Say,
Wait.
when you go to the mobile computing, here this one C double plus, you hear this one Android Studio. You have the this one is actually what's that? Swift language, right? You have Objective C, that's actually for iPhones. That's a mobile language. Desktop language, you have the C double plus, C sharp, Python, Java, and C, right?
So Java's like compatible for like almost everything, like a lot of things.
Yeah, actually it's compatible with a lot of things. But and then you have the markup language for the website construction. You have this Python, Ruby, whatever for database. You have the numerical computation with the Python, Java. This one called Scoop. Scoop is actually run on Java virtual machine, the elephant one. And then the MATLAB. MATLAB, I told you, is not what's that for. Actually, that's we are trying to run the Python for PyLab, right? That's numerical computation for math. Okay?
Yeah.
And here are a lot of different languages.
Then when people were like still developing computers, did they use like the machine code, like like all the numbers and hard to read thing codes? Because they didn't have Java at that time, so did they just use like?
At that time, they use this. They use assembly.
But how did they?
They have an assembler that translates to machine code.
Oh, okay. So they developed the language first, and then they.
Yeah.
Okay.
Yes. But back in that time, actually, it's not like the electronic code. Okay. Back in that time, the computing, the first programming language, it's not done in. It's not even done in text like what we see here. Not like this. Now you're typing. It's called punch card. It's a little bit like, in the 1960s something, programmer not really write English code, it's write something like this. You punch a lot of hole in there, and then the program actually is like 0, 1. Like your SAT ABCD thing. You know what I'm saying? So here, this one is the Fortune data, you see. Essentially, Fortune data is coded in this way. So it's not a punch hole. Not actually make a. So it actually is like something like a car.
Oh, so
these ladies, you see this lady on the hand, 1950s, they use a punch hole reader, punch hole card. So a program actually like maybe have 100 different cards, and then they fit into the computer. See?
Oh, so it's like one of your Scantron things.
Yeah. So something like this one, this person put the card into the machine, and the machine is like this, not like now the way you see. Right?
Yeah.
The computer is like a whole control center, like nothing. So that's this one is the NER, an IBM computer, 360 something like that. It's actually something like that.
Oh, so like they didn't use like USBs or anything. They used like punch.
No, it's something like this. Actually, it's like card.
Yeah. Okay.
Okay, IBM AT card and punch card format and capture code. So each one line actually is a ABCD representing for some ABCD.
And then how do they? So like each hole kind of punches a command.
Yeah, actually a later. Like you have a combination, so each line of the is only a later. So this card may be just one statement.
Oh, so just because they didn't need to use that many lines.
Yeah. At that time, it's actually pretty simple.
Okay.
You cannot do so. It's actually a lot of these things back in the old days.
Each of them are like one word.
Someday you start to have these. That's a great invention already. When they have first people, that's great invention already.
Oh, okay.
Okay, so that's what you should do. And then the printout is a tape.
Yeah, that's kind. Each one of them are like looks like a byte.
Yeah, and then it's at that time is a printout is like a tape. It's like you store data into the tape.
Oh, and it holds a lot. Okay.
Yeah, it holds. Nowadays, if you look at a tape, it's probably just a few kilobytes. It's not a lot of size. So and then later they start have first mini computer, micro computer is something like this. The first generation of the machine is like this. Okay, it's HP Museum. So the first computer I bought like about 1985 might probably look like something like this. The first computer I bought. Okay, so that's old days, you know. And then Windows become available like around 1990. So Windows become available when I was in college. Okay, so before that actually there's nothing like that. Okay. Now these are okay. Okay. Now let's go back to our Java. Okay.
Okay.
So we have enough of the basic programming language stuff. Now actually let's go back to Java. Okay. So let me write a very simple Java program. The simplest Java program. So the simplest Java program type A. Okay, and then I remove everything. And then I say A. I say class.
Why do you have to write class?
A. Okay, so this one is the simplest program is like this. It doesn't do anything, but actually it's a legal way of doing anything. So when I compile, it passes. But you cannot do anything, okay?
Mm.
As for why it's called class, it's a long story. So let's not talk about it right now. It's too much. Later you will know. So after we have a class, then the first thing you need to have is public static void main. That's your main function. Okay, and you put it here. Then you have the first program like this. Pretty much very short. But you have a main program, but this one is runnable program, smallest runnable program. It runs, but it has nothing because you didn't do anything.
Yeah.
So only have A, and without it two line, it's actually the smallest legal program. With the past public static void main, is the smallest runnable program.
It's good.
And then the next thing, is like, if I have some garbage, you know, I want to type like this, two line, backslash, that's what's called command lines.
Yeah.
Whatever being commented out become inactive. So these are command lines. Okay, so what command I usually this Booj will generate is will be something like this. Let me copy it back to this A class. So if you have a double slash, that's a command line. Here, this one is another command line format.
Yeah.
Okay, so let me bring
Wait, if you remove the stars in the middle, it still works, right?
Yeah, it still works. Let me explain this. Okay, here I can put my name in there, right? And it's when I put a date, say this one 06/01/2018. Okay, so here I have the first way for commenting signals. I can write here of comments, right? And I can use this single star one, comment style 2. Okay, and third one is for this double star one. Okay, so there are 3 ways to do comment. And what's the difference for these 3 different way of doing comment?
Well, I know just 2 slashes does just that line.
Yeah, just for the line. So let me show you by whiteboard.
So what does the 2
okay,
star do?
So double slash one is what happen when I say a equals 3, right? But later I regret I don't need this line, but I don't want to delete it. So I put a double slash. So this line is commented out and become inactive.
Okay.
Okay? And then the second one, this one single star. Single star, you just need this, okay, a pair. And then when will this happen? If I have a equals 3, b equals 4, c equals 5, but later I decided to comment this out. I put a set of slash star star slash. So this in the middle become inactive. Okay, so this one double slash to comment out one line, star slash star, and then star slash is usually for a commenting out for a block. Okay.
And what about double?
Okay, let me show you what's double for. Okay. Okay, double one, I finished some program like this, right? Now let me actually here. Let me actually do something. Okay, let me put back this one. Okay, then I can run, right?
Yeah.
This one I can run. Now, here you see here, right, as a source code, right? You put the documentation. So it gives you a documentation page. So you remember that in my program, okay, let me bring back the source. Right here, I write author, Eric Chow, and then the date, right?
Yeah.
And if I go to the documentation, it generates here, author version right here.
Oh, so you can change that if you want.
Yeah, actually you can see this. Okay, now let me go back to my source. So right here, if I have this, and inside my function, right, I start here, and I say main function, right, and then I parrot.
Does it automatically do the stars?
I say args, so it's like I can say the arguments for the main function, something like this, right? So I have a double star thing, and then I compile and save, right? And I go back to documentation. So here, you see here it shows the main function. Main function public, main function, args, the argument for the main function.
Oh,
so if I go back here, and I don't do this in the argument of the whatever, and here I put I am stupid, okay, and then I see what happened. So now it become I'm stupid.
Okay.
Is that okay?
Yeah.
So that's how you actually. So here actually, okay, you shouldn't write something like this. It's something like, okay, I write a program, right? I make it as a documentation. And what's the purpose for documentation like this?
Just so you know a little about the program before it starts.
Yeah, and actually, maybe 2 years, 3 years later, you are not the guy who write the program, right? And then here, I apply here the documentation and generate this page, right? But in my folder, in my Eastern test directory, and then I have an A class over here. So if I bring up this by this, it's still the same. It's the same as what I see in here. Just like a text file, just like a normal text file. It's the .java file is like a text file. I can open by different editor. So here, if here I am and put in here, this is good. Say, right? I say this is good. Then I actually save us. No, I should be doing save us. I should do save.
But right? if you don't do the app param args, would that still save it as?
Let me do this. Okay. And then I actually close the file, and here I actually open again. Wait, it doesn't go back. Let me actually close this one. And then let me open the project again. Right here, select. Okay. Now you see this is good, right? So the two can actually access into the same file. Is that okay? What's your question now? The previous question you were trying to ask.
So if you don't, on the code you wrote like /*, at param args.
Yeah.
Like if you don't write that, would still write it into the document?
No. So say if I delete this, no.
I mean like if you don't take out the app param args, like just that type, like those.
So for example, if I don't do the double star, I just.
I mean not that one. Like the you double star still, but can I edit your thing?
Okay, so you don't like this parameter. You need.
No. I mean like you take out you keep the main function, but you take out the app param args.
And then the argument will not have discretion.
Okay, so it wouldn't be an argument, right?
No, it shouldn't be. So actually, this line is to describe this arg.
Okay, so I'm talking about like you split the line in half, like the first part of the param args.
Yeah.
Is that the type of code like you use to write in the document?
Yeah. Okay. So say let me show you another thing. Okay. Now I have a main program, right? So for example here I have another function called public static for integer and then print 5, right? And then this function would be I will return 0, right? And then right here I will say system.out.print line, right? Let me print the file over here, right? And this one actually I can write this, right? And I say print 5, print out of 5. And here I say if say now if I don't have anything, right? I didn't do anything right here, right?
Yeah, you didn't write the app param.
Okay, then let me do this. I come back to here. I have a print file, method called a print file, and then it has no argument. In the print file, no description for argument, right? You see my screen here?
Yeah.
Print file, I have no argument. Now I go back to source, and then here I say add parameter, and then here I say let me put here. Okay. And then I print X, say, and here I call it once.
Okay.
Okay. Then actually I compile. And right here I say this one for X. So
Why didn't you write the args?
yeah, let me see here. Okay, if I put the X parameter and return, right?
Mm-hmm.
And then I go back to documentation page. You would have a parameter, right? And you would have the returns.
Oh, okay, that makes sense.
Is that
Yeah.
okay?
Yeah. Okay.
And then I go back to my my directory. There is a DOC, right? There is an index file like a normal web page. And then say I open by I can do two ways. I can open by browser, by Google Chrome. So you will show like this.
Mm-hmm.
Okay? And I can also show by, I can also print up by this bracket. So I bring up another editor. One moment. Okay, right here, right? So it's over here. It has a JavaScript, Java. It has HTML file and the Java. Okay, and then I hit this return. Hit this one. It also will bring up the index file. Of course, I can do editing for HTML over here. Is that okay?
Yeah.
I can change it right here.
Okay.
But that's how it works. Okay, so the BlueJ is a whole system that provide you the tool to run and compile your tool, your language, and then you provide the documentation page as well. And right here, say, if I actually close my BlueJ,
Mm-hmm.
if I close my whole BlueJ, right, but I keep this guy on, right, I keep this guy on, and then here in this window, I can actually type the window key plus R.
Yeah, and then that does registry thingy.
I can do this, and then here I actually hit the window key with R, and I say command, right? This one I showed you before. And then CD space, and this one I copy the directory over.
Yeah.
Right, and I hit return, and I can do dir, right? I'm sorry, I can do dir.
Yeah.
Whatever available right here, right? Then I can say Java C base a dot Java. Java C means Java compiler. Compiler, and then hit return. So it do compilation for me. And then I say Java, that's Java virtual machine. I type A for A class. Hit your run and then print out the data. Is that okay?
Yeah.
And right here, I change this to, actually, let me change it to 100, right? Instead of returning 0, I returning X, right?
What is that?
And then its return value that will be, the function will return the value. And here, I don't say hello world, I change it to, well, I change it to welcome Java program. Okay, that is. And here I say save. And then I go back to here, I say Java C compile, capital A Java.
Okay.
I say Java and then run A class. See, it will give you the welcome to Java programming. So the way I use this one called Notepad double plot,
Oh yeah.
and also combine with this command line, it can also do the compilation.
What does the return do?
Return is actually, this is called a function, right?
Yeah.
What is a function?
Just like it's like a part of a program.
F of X equals x squared, right?
Yeah.
So the y is the return value.
Mm-hmm.
So if you have the f of 3, y should get 9.
Yeah.
Same thing. So let me change this. If I
Also, saying you put in x into the equation.
yeah, so here say let me change it, okay?
Okay.
So here instead of having this print 5, let me say actually square, right?
Mm-hmm.
And instead of printing this in now, I don't need to print that anything.
Okay.
And then I say x times x, that give you the square, right?
Yeah.
And here I say I put in 3, right? It's not 0.5 now, it's actually square, right? So here I say, here instead of saying like welcome, I say square of 3 equals, and then I don't need these two stupid comments. I delete this.
What was the point of writing x instead then?
Let me, okay, just do this. I actually save and go back to here, and then here I do Java C8.java, and then I do Java A. Now it says square of 3 equals 9.
But what was the point of writing like x? If you could, you didn't have to. Do you have to write x?
If I don't have x, then I don't. Okay, the purpose of having an x is that I change to 6, right? And here I say Java C8.java, and then I say Java A. It becomes 36. So you put here, you put a 3 in there, you return 3 times.
Oh wait.
You put a 6 over there, you return 6. 6 by 6 is 36.
Oh okay. That makes.
So
Oh okay, yeah.
So if I put a 9 over here, what would be the return value?
81.
Yeah, it will give you the 81. So here I say Java C8.java. Okay, and then I say Java A.
Okay.
Is that okay?
Yeah, I forgot.
Okay, so now it's 7:20. Because I told your mom that I'm trying to be light today, okay? It's not regular schedule. So is that okay for today? And then next time we will start chapter 1. Is that okay?
Okay.
So I have the recorded, so I would, after this session end, I will send you a link from YouTube, and you can check this program, this video again.
Okay.
Okay, and then you can review. And then next time if you are okay with next time, we can meet next week. What's the time? 6 o'clock Tuesday.
Okay.
Is that okay?
I have to check with my parents again.
Yeah, you have to check your schedule.
Okay.
My original schedule is like every Tuesday. I'm sorry, Monday, Wednesday, 6 o'clock.
7 o'clock.
No. I'm sorry. That's my Pacific time. Your Central time is 8 o'clock.
Sure. I need to go check with that though.
You check with your mom, okay?
Okay.
Yeah. So you are in summer, right?
Yeah, it's school just ended.
Okay. So then you check with your mom. I told you to your mom as well. Is that okay?
Okay.
And then next time we will be full-blown version. We will start to do chapter 1, 2, 3, and then try before the end of summer to reach about chapter 11.
Okay.
Okay. And then right now you're on this Sing Java. That's introduction to Java programming. And in early August, we will change to this one called Java Programming Essential,
Mm-hmm.
and that is the AP Computer Science A course. Okay.
Oh, do you want me to like do anything by myself? Like I can
Yes.
Java.
Later I'll give you the homework, and then
Okay.
yeah, and actually, if you are quick, you can do whatever you want to do.
Like, do you want me to watch the Think Java also?
You been read this? You can
No,
read by yourself.
no, I mean like you have a video.
Yeah, you can read that. You can read that, and then
Like,
after you read that, if you are okay, you can actually work on the homework right here. There are a bunch of homework. You can return to me if you finish that.
okay.
Is that okay?
Yeah. But I mean like,
Every class meeting right now, we will start from chapter 1. And if you are faster than that, I'll check. If you are okay for some chapter, we just try to speed up. Is that okay?
okay.
So that actually you can start from chapter 1. And that's the purpose I send you among the C Java part. Okay?
Like the videos, right?
Yeah, that's why I did. If you don't need that, then I don't need to send it, right?
Yeah.
And right here, actually, let me show you. Okay? So right here, let me show you. Okay, this one actually, I probably showed you one, but maybe not showing to you. This one is actually I don't know what high school program your school district support. But right here, actually, you are in the summer. I put you on this program called Introduction to Computer Science Java program, right? And in fall, you are going to this APCSA, right?
Yeah.
You're taking that. So we try to finish about chapter 11 at least.
But I think we're doing intro to Java. I think my school only does intro comp sci.
Yeah, it's the same thing. Intro comp sci or intro Java
Yeah.
is similar.
No, we do AP comp sci principle. I think. I forgot what we do. But
That's
basically,
this one. Yeah, that's this one.
I forgot which one we do.
Yeah, it's okay. But the course I'm going to teach in fall is this AP comp sci A.
Oh, okay.
I don't know whether you take this one or this one. You have to be careful. The one I'm going to teach is this A, not this CSP one, not this principle.
I think we might be doing principles.
Oh, you have to check out, okay? You really need to
Okay.
check out. This P is for non-CS major. This P is for non-CS major, okay? Non-CS major. P is not for non-CS major. A is for CS major.
Okay.
So let me show you the difference. You have to check it with your school. So this one is intro to comp sci using Java, okay? The one we use in summer. So here is the comparison chart. So ABCS A, the STEM major, right?
Mm-hmm.
And it actually demand higher 95% programming. The P one you talk about is only 60% programming. Is for liberal arts and the STEM. Okay, so this one is actually not for CS major. This one is non-CS major. Okay, this one's more like CS major one.
Oh wait, I'm doing the one that's AP. I forgot what it was.
Both are AP.
Oh wait.
So one is called P principal, one is called A.
Yeah, I think it's CP.
Yeah, you have to figure out. Okay, this one is way lighter. Okay.
Yeah, that's what our school does.
That's way lighter. You can take this in school, but if you don't get an A and you still want to take A exam, I can suggest you some weight course.
So like they're kind of like the same thing, but like
no, it's totally different.
CSP is way easy. Okay.
No, it's totally different thing. This one is more like a Python based.
Okay.
And this one is Java based.
Yeah, my friend said that. My friend just told me that they have comp sci A in my senior year.
Yeah. So when you do the exam, the A1 actually is multiple choice with the free response. The one principle is only multiple choice, no FRQ, no programming contest. It's only for ABCD type multiple choice test.
Okay.
So two are different actually.
Yeah, they're.
You have to make sure which one you are in, okay? And then
we're doing principles.
Yeah, if you want to do this A1, the one I'm going to teach in 4 is actually what is ComSci A.
Yeah.
Okay, the one I'm going to teach is ComSci A. It's for CS major, and maybe your school only allow senior to do that. But
Yeah.
for me, it's not. It's okay if you still want to take this one. I can suggest you how to do it. Okay.
Okay.
I'll talk to your mom actually. Then I have to make sure that she understands the situation for your school.
What's the difference between ComSci A and ComSci? Like I saw something like EV or something.
I told you this one principal one is using Python and
Yeah.
Scratch, simpler and non-CS major.
Yeah. I mean, like I saw another one, Computer Science A,
Yeah,
and like Computer Science AB or something like
the
that.
AB is obsolete. It is no longer offered.
Oh, okay.
So now it's only A. AB and A is just like your AP calculus B, C, and A.
Okay.
That's a different difficulty.
Oh, okay. I think that's it.
Is that okay?
Yeah.
But you certainly need to talk to your mom and figure out from your school which one you actually will take in the fall and next year. And if you still want to do A exam, I can help you on that.
Yeah. I can still do computer. Like, does Computer Science A help with principal?
Yeah,
I kind of get it, right?
it overpower it actually.
Oh, okay. Then yeah,
It
that should be fine.
definitely will overpower it. It
Yeah.
definitely will overpower it. Okay?
Okay.
Then probably see you next time.
Yeah.
Okay, bye now.
Okay. Thank you. Thanks. Bye
Bye
bye.
bye.